and welcome everyone. Today we will complete the most important topic from the previous year. Let's start.
The valency. To understand what is the meaning of valency, look at these examples of chemical reaction. Example number 1, formation of sodium chloride. During the formation of sodium chloride, the sodium atom tend to lose the outermost electron, as you can see, and change into positive ion, while the chlorine atom tend to gain this electron and change into negative ion. This electron whose loss or gain called valency. The second example, formation of oxygen molecule. During formation of oxygen molecule, each oxygen atom share by 2 electrons. This atom share by 2 electrons and this atom share by 2 electrons. These electrons called valency. The third example, formation of sodium fluoride. During formation of sodium fluoride, sodium atom tend to lose the outermost electron and change into positive ion, and fluorine tend to gain this electron and change into negative ion. This electron which lose or gain called valency. From the previous examples, we can conclude the concept of valency. Valency, it is the number of electrons that an atom gains or loses or even shares during the chemical reaction. Some examples of valency. Example number 1, sodium. The atomic number of sodium is 11, so the electronic configuration of sodium 281. Sodium atom tend to lose the outermost electron during the chemical reaction and change into positive ion. So we can say the valency of sodium is monovalent. Monovalent meaning sodium atom lose 1 electron during chemical reaction. Second example, oxygen atom. The atomic number of oxygen is 8. So the electronic configuration of oxygen 6. So the oxygen atom tend to gain or share 2 electrons during chemical reaction to complete the outermost energy level with 8 electrons. So we can say the valency of oxygen is divalent. Divalent meaning the oxygen atom loses or share or gains 2 electrons during the chemical reaction. Another example, chlorine atom. The atomic number of chlorine is 17, so the electronic configuration of chlorine are 287. Chlorine is non-metal, so it tends to share or gains electrons during chemical reaction. The outermost energy level of chlorine consists of 7 electrons, so the chlorine atom tends to gain 1 electron during the chemical reaction and change into negative ion. So we can say the chlorine is monovalent. Monovalent meaning chlorine tend to gain or share electron during the chemical reaction. Another example, magnesium. The atomic number of magnesium is 12. So the electronic configuration of magnesium are 282. Magnesium is metal, so it tends to lose electron. The atomic group. To Understand what is the meaning of the atomic group, let's study some examples of atomic group to understand the concept of the atomic group. Example number 1, ammonium group. Ammonium group, as you can see, consists of one nitrogen atom linked with four hydrogen atoms. Nitrogen atom joined with four hydrogen atoms form group called ammonium group. This group during chemical reaction behave as a one atom and has own valency, which is monovalent. Another example, hydroxide. Hydroxide group consists of two different elements, which are oxygen and hydrogen linked together, but during a chemical reaction, they behave as a one atom and has own valency, which is monovalent. Another example, bicarbonate consists of three different elements, which are hydrogen atom linked with carbon atom linked with three oxygen atom to form this group. But during a chemical reaction, these different elements behave as a one atom and has own valency, which are monovalent. Nitrate consists of nitrogen atom linked with three oxygen atoms to form this group. But this group during a chemical reaction behave as a one atom and has own valency, which is monovalent. Nitrite consists of two different elements, which are nitrogen atom linked to two oxygen atom. This group during chemical reaction behave as a one atom and has own valency, which is monovalent. From these examples, we can conclude the concept of the atomic group. Atomic group is a set of atoms. As you can see, this nitrogen atom, hydrogen atom, oxygen atom, hydrogen atom linked with carbon, linked with oxygen, all of them called set of atoms of different elements. Nitrogen, hydrogen, oxygen, hydrogen. There are different elements. Hydrogen, oxygen, carbon. They are different elements joined together and behave as a one atom during the chemical reaction and have own valency and it's not exist slowly. Another examples of atomic group. Carbonate CO3 negative 2, its valency divalent. Sulfate SO4 negative 2, its valency divalent. Phosphate O4 negative 3, its valency trivalent. Chemical formula. As we knew before, each element has a symbol of one capital letter or two letters. The first one is capital and the second one is small. To express a molecule of compound, we use a chemical formula to show the number of atoms in this compound and the number of elements forming it, such as carbon dioxide gas molecule. As you can see, it consists of one carbon atom linked with two oxygen atoms, two different elements with three atoms. The second example, water molecule, consists of two different elements, which are two hydrogen atoms linked with one oxygen atom, two different elements, and three atoms. Now we will know how to write the chemical formula of compound. Step 1. Write the name of compound. Calcium oxide. Step 2. Write the symbol of each element or atomic group down to its name. The symbol of calcium is Ca. The symbol of oxide meaning oxygen. Step 3. Write the valency down to each sample. The valency of calcium is divalent. The valency of oxygen is divalent. 4. All numbers are to be shorted as much as you can. Step 5. Replace the written numbers under the sample. Replace the written number under the sample. At last, the chemical formula of calcium oxide is CaO. Another examples, magnesium hydroxide. Step 1. Write the name of the compound, magnesium hydroxide. Step 2. Write the sample of each element or atomic group down the name. The sample of magnesium is Mg. The sample of hydroxide is OH. Step 3. Write the valency down to each sample. The valency of magnesium is 2. The valency of hydroxide is O. Step 4. All numbers are to be shorted as much as. Step 5. Replace the written number under the sample. Replace the written number under the sample. At last, the chemical formula of magnesium hydroxide is MgOH2. Number 3. Aluminium oxide. Step 1. Write the name aluminium oxide. Step 2. Write the sample of each. Write the sample of each element or atomic group down its name. The sample of aluminum Al. The sample of O. Step 3. Write the valency down to each sample. The valency of aluminum trivalent. The valency of oxygen divalent. Step 4. Replace the written number under the sample. At last, the chemical formula of magnesium oxide Al2O3. Chemical equation. If you burn a magnesium strip in air, magnesium combines with oxygen during burning, forming white powder of magnesium oxide. This chemical reaction can be represented by the chemical equation as magnesium plus oxygen by heat magnesium oxide. As you can see, this chemical reaction represented by this equation. So we can say the chemical equation about the set of sample of magnesium, sample of oxygen, sample of magnesium oxide, and divided into two sides. The left side that represented the reactants and right side that represented the products, and this small triangle represented the heat. From the previous explanation, we can conclude the definition of the chemical equation, which is it is a set of samples and chemical formula representing the reactants and products molecule in the chemical reaction, and it represents the condition of the reaction as well. Note: a chemical equation should be balanced. This means the number of reactant atoms of an element should be equivalent to the number of atoms produced from the reaction. To explain what is the meaning of this, note, look at this example. Formation of water molecule. During the formation of water molecule, 4 hydrogen atoms joined with 2 oxygen atoms to form 2 water molecules. Look at the number of hydrogen atoms in the reactants. There are 4 hydrogen atoms in reactants and 4 hydrogen atoms in products. The number of oxygen atoms in reactants, 2 oxygen atoms in reactants and 2 oxygen atoms in products. This means this reaction, this equation is balance, meaning the number of atoms in reactants equal the number of atoms in products. Another example, look at this reaction. The number of carbon atoms in reactants is 1. The number of carbon atoms in products is 1. The number of hydrogen atoms in reactants is 4. The number of hydrogen atoms in products are 4. The number of oxygen atoms in reactants are 4. The number of oxygen atoms in products are 4. This means this equation is balanced. From the previous examples, we can conclude the number of atoms of each element in reactants must equal the number of atoms of the same elements in the products.